This week on the show, we have a website protection with OpenSense article for you. We also cover FreeBSD support, the pull request for ZFS on Linux, which is exciting. We also cover how much has Unix changed over the years, the report from porting Wine to AMD 64 on NetBSD, FreeBSD Enterprise 1 petabyte storage is also what we have as an article, and we talk a little bit about the death watch for X11, which has started, and more in this week's episode of BSD Now. BSD Now, episode 305, Changing Face of Unix, recorded on the 3rd of July 2019. Hello, I'm your host, Benedikt Treuschling.
And I'm Alan Jude.
Welcome back to our episode this week. We have great headlines for you, as always. Every week there's something interesting, and this time it's the website protection with OpenSense. So here, this is on Medium, blog post by Julio Cesar Camargo, I think. And starts off with the OpenSense security platform can help you to protect your network and your web servers with the Nginx plugin edition. So with that, he has as a subtitle, with the Nginx plugin, OpenSense becomes a strong, full-featured web application firewall, or WAF. So it's a little bit like a little how-to. He walks through the steps of installing OpenSense. And this starts with, in the old days, install an open source file was a very tricky task, but today it can be done with a few clicks or keystrokes. And in this article, he'll describe the detailed OpenSense installation process. You can also watch a video that he has that was extracted from the OpenSense course available at Udemy or Udemy. I think it's Udemy.
I think it's Udemy.
Yeah, the video is in Portuguese language, but with the translation subtitles that YouTube provides, you may be able to get into the most important bits of it and follow along without any problems.
But that's just if you need to know how to install OpenSense. So if we skip ahead to actually, you already have an OpenSense and you want to set up this plugin.
Yeah, so they walked through the initial steps. They show a couple of screenshots and where you need to make edits. And then further down, find that once you set it up, you first download the NAXSI, the WAF rules. So these are the rules that you need for your Nginx anti-cross-site scripting and SQL injection parts. So that's the acronym for NAXSI. And so they write that technically it's a third-party Nginx module available as a package from any Unix-like platform. This module by default reads a small subset of simple and readable rules. That's important in firewalls, readable rules. Containing 99% of known patterns involved in the website vulnerabilities and similar things. So once you have those policies, there's now a submenu you can find, and that's also called NAXSI. And then you can look at those lists, of course, and further down, you will find a description, URL patterns, and so on. And then you start with the HTTP server. You create your website front end for that. A couple of edits, all nicely for you to follow along with screenshots, so you never get lost. And then it's part 6, OpenSense configuration adjusting. So you enable the Nginx service without any port conflict problems so that they don't overlap with the port that's already been used. And then you need to make some changes in the web GUI. So that's also illustrated with pointers. And then the final step is to create the required firewall rules to allow the HTTP/HTTPS traffic on the desired network interface.
Yeah, so basically, by default, the OpenSense is going to be using the ports you would normally use for the web server for its management interface. And so you're going to change them to a different port so that you can direct your web traffic at the OpenSense and it will firewall it and filter it before sending it on to your application so that these types of attacks and common scans and so on will be blocked at the firewall and at layer 7 rather than going past and getting to your application.
Yeah, before they actually reach your website or whatever you have behind HTTP.
Sometimes it can even just be as simple as you have some older appliance of some kind that does not have HTTPS.
Oh, yes.
And you want to enforce that, you can just make it only accessible via the Nginx this way, so that you always have SSL to the Nginx on the OpenSense, and then the unencrypted connection is only on your LAN, and it's a little bit nicer that way.
Mm-hmm. Yeah.
I imagine you could also use this OpenSense Nginx plugin to require a username and password in order to access the web interface on stuff. Especially when you get things like if you need to make it so that you can access your switch web interface to configure it or something, you don't want that exposed to the internet.
Yeah, better not. Yeah, just in case you get someone accidentally stumbling upon that.
Yeah, and the other thing that this Nginx can do is if you only have one public IP, but you have 3 different web servers on your LAN or whatever, it can do the host-based, like looking at the host header and deciding which of those machines on the LAN to forward it to. So you don't need different port numbers or different IP addresses. You can actually do the differentiation of which of those multiple web servers in the backend you talk to based on the request coming into the Nginx.
Very cool. And very easy to set up with the screenshots provided and a little bit of descriptions. You should be able to protect your vulnerable website a little bit better this way.
So next, we have FreeBSD support pull request for ZFS on Linux. It's the first draft is now there. So over on the ZFS on Linux repo, there's a new pull request, number 8987, that adds support for FreeBSD to the ZFS on Linux repo. So as we've talked about a bit before this, there was a copy of the Illumos repo, and everybody kind of pulled that down and then added their own changes to make it work on their OS. So on FreeBSD, we had the OpenSolaris compat library and a bunch of tweaks and ifdef FreeBSD stuff added to the code to make ZFS work on FreeBSD. And Linux did basically the same thing. They have their thing they call the Solaris porting layer, and they did all that stuff. And most of the ZFS code is the same between them, but over time, new features have been developed on each platform, and as well as lots of bug fixes and so on, and they didn't always get pushed back everywhere else. So the idea now is to commonize this on one active repo. So the first step of that is after we've got FreeBSD caught up to the latest newest version of OpenZFS, we then did a pull request to integrate the FreeBSD specific bits back into that repo.
Exciting.
Once that's done, and once that gets integrated, that will mean that the code in that repo will be able to build both FreeBSD and Linux from the exact same source code.
Okay.
It also means that we will get FreeBSD hooked up as part of the continuous integration testing. So every time after that, when someone opens a pull request against ZFS on Linux, it will have to build on both Linux and FreeBSD before it can be merged.
Excellent.
And then, as was officially announced in last week's ZFS leadership meeting, once the FreeBSD bits are integrated, the repo will be renamed from ZFS on Linux to just OpenZFS, because it won't be specific to Linux or FreeBSD or anything else. It will be the OpenZFS repo that contains support for multiple operating systems. And we expect over time that the macOS and Windows ports will be integrated in the same way. And I imagine someday Illumos. Right now, Illumos is going to keep just pulling individual patches. But in FreeBSD, we looked at that, but because things have happened in different orders in different repos, it's very difficult to pull, to basically extract individual features in order to merge them. And that's why we decided to do this kind of rebase instead of continuing just pulling in pieces at a time.
Yeah, in the long run, that's easier to do, to maintain.
But it basically, what it consisted of was adding FreeBSD support to the repo to refactor the code to separate out any OS-specific bits. So under modules ZFS, there was all the code for Linux, and ZFS was kind of mixed together. But now there's module OS Linux and module OS FreeBSD, and all the OS-specific code lives there, and the ZFS code is in the ZFS directory, and if it needs to do something that's different on the OS, it kind of goes through this Solaris porting layer. And so we imported FreeBSD's version of the Solaris porting layer that basically turns the Solaris calls that are in the ZFS code into FreeBSD code, the same way that Linux turns those Solaris calls into Linux code. So with that, it means that the ZFS code will be cleaner and will basically be OS agnostic.
I like that.
And there's a few if-defs in places where it didn't make sense to basically duplicate the code into separate files in order to have a couple lines be different. But we'll see how it ends up, as we get the review feedback and decide on each case if it makes more sense to actually split things out or make subroutines or what. Another huge part of the undertaking here was to adapt the ZFS test suite so that all the tests can run on FreeBSD and not only on Illumos or Linux where they were maybe originally built, and get it to the point where when running under FreeBSD, every test that passes on Linux passes on FreeBSD. I think there are like 5 or 6 out of the thousands of tests that are known not to work right now or to intermittently fail. But all the ones that reliably pass on Linux now pass on FreeBSD.
Excellent. That probably required a huge amount of work.
Yeah. So as this moves forward, it will mean that ability to move code back and forth between FreeBSD and Linux for ZFS will get much faster. Because basically, once you add the code for one, if it's merged, it means it already worked on the other one.
Yeah, that will be the day when we actually get more features down the line.
With the port here, we're basically at feature parity for if you use the Open ZFS port on FreeBSD. It has all the features that Linux has. But as we get this sorted out, it'll mean that we don't have to do as much work to keep caught up because we'll just keep it working instead of always having to go pull in new stuff as it happens. Yeah.
With the upstream coordination is a lot of the work already done.
Exactly. It's something that the FreeBSD project tries to tell people who use FreeBSD all the time. Hey, if you upstream your changes back, it'll be less work for you to carry that diff. Well, we're doing the same thing with ZFS.
Just the other way around.
But, you should practice what you preach, basically.
Yeah, so that's a good thing that we're going to see in the near future. More near than far.
And so this will allow improvements made in one OS to more easily and more quickly be available on all the other platforms. So I also included in the show notes a link to the video from the leadership meeting, which is about an hour long and happens once a month. And a link to the meeting agenda and notes if you want to read more about the details and look at stuff from previous meetings and so on. But it has the bit where we talk about changing the name of the repo and the status of ZFS on FreeBSD and so on. Then I pulled out a recent example of a bunch of work that Alexander Moten has been doing to improve performance in ZFS. Some of that is now landed in FreeBSD. In the future, that means it'll be available on the other platforms very quickly. So Mavs Chains added a new API called WakeUp Any, which is basically a cheaper version of WakeUp 1. So the WakeUp Any API and its underlying sleep queue signal function spend additional time trying to be fair, trying to wake up the thread that has the highest priority, which is the one that's been sleeping for the longest time. But in the case of a task queue, where there are many absolutely identical threads, and any fairness between them is pointless. In general, ZFS is going to spin up a task queue on each CPU, and they're all exactly the same, and we don't really care which one does the work. So the WakeUp 1 API that tries to be fair and wake up the thread that's been waiting the longest is actually the opposite of what we want to do. To make it even worse, since round-robin wake-ups not only make the previous CPU affinity in the scheduler useless, they also hide from the user a chance to see any CPU bottlenecks, because it'll use CPU 1 for the thing, and then CPU 2, and then CPU 3, and each one's only a fraction of a second, so it doesn't really show up in top. If it's not busy, we might as well just use, the task queue that's already awake.
Okay, yeah.
So this hides the user's ability to see any CPU bottleneck because it's spread out. But if we focus it, it wouldn't be. So when sequential workload with one request at a time will look evenly distributed instead of just being one hot thread. So this change adds a new sleep queue unfair flag to the sleep queue signal API, making it wake up the thread that went to sleep the most recently. So the one that's been asleep the least amount of time instead of the most amount of time. but no longer in context switch, so that if a thread is in the process of going to sleep, we'll find one that's already asleep instead of waiting, so that we don't have to spin on the thread lock. So on top of that, the new wake up any function is added. It's an equivalent to wake up one, but sets that extra flag. This means this is also good for just CPU scheduling, because if we already have one CPU that's awake, it lets the other cores actually stay in the deeper sleep state and might actually basically result in power savings as well as performance improvements.
Okay, that makes sense.
But in his testing with a 72-core Xeon V4 machine doing sequential ZFS writes to 12 different ZVols at once with 16K blocks, the new code spends 74% less time in the wake-up functions and their descendants, and the total write throughput was increased by about 10% using the same CPU as before and after.
Okay. I think it's 34. I think you said 74.
No, 34% less time spent in basically waiting for locks and stuff.
That's it.
And resulting in a 10% improvement in performance.
That's definitely a nice improvement. And that's something that will be seen by or felt by users.
Yeah, especially if you have a lot of CPU cores.
Yeah. This might not be your ideal or your current configuration in number of cores, but eventually...
Right, but the same thing can apply, especially on a desktop, where the CPUs might be busy doing other things like web browsers and stuff. Using the CPU, especially on a laptop, using the CPU that's already awake instead of waking up the one that's been asleep the longest is actually likely to result in battery power savings or battery life savings.
That's certainly something people should try out and see for themselves.
Yep.
Excellent. That's great news. Time for a news roundup this week. We have episode 5 notes. How much has Unix changed is the question.
Yeah, so this is from the podcast Advent of Computing.
Okay, yeah, that's the very early beginnings. And you can see from the picture here that they are really going back into history. They start their article with, Unix-like systems have dominated computing for decades, and it's the rise, and with the rise of the internet and mobile devices, their reach has become even larger. True, most systems now use more modern OSs like Linux, but how much has the Unix-like landscape changed since the early days? So the question they asked themselves was, how close is a modern Unix userland to some of the earliest Unix releases? To do this, they're going to compare a few key points on a modern Linux systems, or Linux system, a single one, with the earliest Unix documentation they can get their hands on. The doc they're going to be covering is the Unix Programmer's Manual from November 1971. So that's already quite old. And it's predating version 4 of the system. They think the best place to start this comparison is to look at one of the highest profile parts of the OS, that is the file system. Under the hood, modern ext file systems are completely different from the early Unix file systems. However, they're still present in basically the same way, as a hierarchical structure of directories with device files. So paths look identical, and navigating the file system still functions the same. Often used commands like ls, cp, move, du, and df functions are the same. So are the mount and umount, but there are also some key differences. For instance, cd didn't exist, yet instead chdir, so change directory, filled its place. So I guess people were just lazy, didn't want to type that much, so they just used cd.
Well, yeah, so chdir is the name of the actual system call, basically. So. Okay,
yeah. But you type that a lot.
Or, well, I don't think it's a system call. libc function, anyway.
Yeah, but cd is easier to type with just one hand instead of... Yeah, okay. Also, chmod is somewhat different. Instead of the usual 3-digit octal codes for permissions, this older version only uses 2 digits. Really, the difference is due to the underlying file system using a different permission set than modern systems. For the most part, all the file handling is actually pretty close to a Linux system from 2019. 1919. No, that's certainly true. Also, not just for Linux systems, but also for the BSDs, because they have the same file system semantics.
Yeah, and we're all emulating the same 1971 computer.
And then the other really high-profile part that they are looking at is the shell. The 71 version of Unix already has a userland shell, SH. A lot of Linux distros actually still default to using a much newer version of SH, but the question is how much of that shell was already set in stone in the early 70s. Surprisingly, a lot. The basic layout of commands is totally unchanged. Command follows by arguments and switches. Both semicolon and ampersand still function as command separators, while file input and output redirects are still represented with less than and greater than respectively. The biggest difference is there are no pipes. These won't appear on Unix until at least 1973. So remember, that is something 2 years later. Also, SH can already run script files in 1971. Overall, they're shocked by how similar the shell seems to today's versions. But I would miss the pipe very much nowadays.
Yes. But yeah, basically they're saying superficially, this pre-release of the first version of Unix is very clearly Unix and similar to what we have today.
Oh yes, and they have a screenshot down there. Oh, look how few switches the ls command has still back then.
Yep. And they also talk about ed, the standard text editor, which apparently isn't available on Debian by default. And they have a Fortran compiler, whereas the for command is now used for for loops rather than as a Fortran compiler.
Ah, good old days.
But yes, it really goes to show just how much of what we think of as Unix we owe to, two people in a lab before most of us were born.
Oh yes, that's certainly true. And they came up with a lot of interesting stuff that is still used today and still the same. Like not internally maybe, but the commands mostly are the same. And so it's easy for people to carry that from one Unix to the next.
Next up, we have a status report from NetBSD's Google Summer of Code project. So this report written by Naveen Narayanan, who's working on this, is working on porting Wine, the Windows emulation layer, to work on AMD 64 on NetBSD. So Wine is a compatibility layer which allows running Windows applications on a POSIX-compliant operating system. Basically translates the Windows API calls into the native OS. So this first report provides an overview of the progress on the project during the first coding period. So they start with Wine on i386. Initially, when I started working on getting Wine 4.4 to build and run on NetBSD i386, the primary issue that I faced was Wine displaying black windows instead of a UI, and this applied to any graphical program that they tried to run under Wine. I suspected that it was related to graphics, and the issue was the graphic drivers or Xorg. Subsequently, I tried building a modular Xorg and tried running Wine on that, and only to realize that Xorg being modular didn't actually affect this. After having tried a couple of configurations, I realized that trying to hazard out every other probable case was going to take a long time. So this motivated them to bisect the repo using Git and find the first version of Wine, which actually started failing on NetBSD. So they started with the last version of Wine that worked on NetBSD, which was 1.9.18. After 2 days of running git bisect, they found the culprit. It was a commit that introduced a single clipboard manager thread per Windows station in Wine. Later, I found that the pthread create calls were borked and didn't return anything. I tried to walk through the code to know where the pthreads library was the problem, and finally they found a seg fault. They realized the address at which a seg fault was identical to the address at which Wine had been throwing an unhandled page fault. I had a hunch that these two issues were correlated. After learning more about memory mapping and the /proc file system, I was sure black window effect was caused by this page fault. Eventually, they found that the pthread attribute setStack was setting the guard size to 64 kilobytes or 65,536 bytes, even though the man page said otherwise. And Wine relied on not having the stack guard set. This resulted in an out-of-bounds access, which caused this unhandled page fault. So after setting the guard size to 0 using pthread set attribute set guard size, Wine started behaving.
Ooh.
And they've discussed this with the Wine devs, and they are happy to upstream it as long as it doesn't cause any inadvertent issues on other platforms. And so then he's got a screenshot here of playing some Mario game from Windows on NetBSD.
Huh.
So then the real big part of the project is getting this working under AMD 64. So compiling Wine with 32-bit support was a bit tricky on AMD 64. I proceeded with a chroot approach as I wanted to know if Wine worked as promised on NetBSD, and if it didn't, to what degree, and what patches would I have to do. So as the first step, compiled Wine on AMD 64 and it ran fine. The subsequent step was to build a chroot environment for i386. I corresponded with my mentors to learn more about the compat32_netbsd package and successfully built an i386 chroot. I had to compile Wine twice under i386 to have it inject the 32-bit components to 64-bit Wine for the WoW 64 support, and to my amazement, it just worked.
Hey, seems like they're off to a good start.
Mm-hmm. So, in summary, they think Wine 4.4 is in pretty good shape as of right now, but packaging it is tricky, especially since you're not going to be able to chroot into an i386 environment as part of the package building because it requires root privileges. I've been writing a compat32 packages for dependencies of Wine to have them cross-compile on AMD 64. I shall be working on getting Wine cross-compiled for 32-bit support on AMD 64 during the next coding period. And on a different note, and very important one, I would like to thank mentors Christos, Zelos, Leo, I forget what his last name is, Maya and Max V for their invaluable suggestions. From where I see it, I wouldn't have reached this phase without them. I'd also like to thank Camille at NetBSD for their support and input.
Oh, great. Then, yeah, we'll hopefully see more from this project over the summer. And yeah, hopefully get a working Wine on NetBSD in the end. Now we have a story about FreeBSD Enterprise 1 petabyte storage. This is over at Vermidon's blog.
Yes, fancy.
Always busy writing up interesting stories about the BSDs and other random sysadmin experiences.
Yeah, so he says, today, the FreeBSD operating system turns 26 years old. As June 19th, well, it's a couple days ago now, but is International FreeBSD Day. This is why I got something special today. How about using FreeBSD as an enterprise storage solution on real hardware? And that's where FreeBSD shines with its storage features, including ZFS. Today, I will show you how to build an enterprise storage appliance based on FreeBSD with more than 1 petabyte of raw storage. And he points out that he has built various FreeBSD-related or FreeBSD storage-related appliances and stuff before, including a distributed object store with Minio, a GlusterFS cluster on FreeBSD with Ansible, and a silent fanless FreeBSD server for redundant backups. But this project is different. How much space can you squeeze into a single 4U system? It turns out, definitely more than 1 petabyte, which is over 1,000 terabytes. So for this particular build, he's got a 4U server with support for 90 to 100 3.5-inch drive slots, which will allow somewhere between 1,200 and 1,400 terabytes of data if you used all 14 terabyte hard drives.
Okay.
So he has two different models to compare to. The Tyan Thunder SX FA100, which has 100 bays, or the Supermicro Super Storage 6048R E1CR90L, which has 90 bays. And so he picked the Tyan FA100 because 100 is a fun number of hard drives.
Yeah.
So he says, well, both GlusterFS and Minio clusters were done on virtual machines or in containers. This is all real hardware. So his build is two 10-core Xeon Silver 4114 CPUs. So that gives him 40 threads at 2.2 gigahertz, 128 gigs of DDR4 memory, two Intel 240 gig data center SSDs for the OS, 90 Toshiba 12 terabyte data disks, and two LSI Broadcom SAS 3008 disk controllers, and two Intel X710 direct attached 10 gigabit Ethernet cards and power supplies. So all in with the hard drives was only $65,000 US.
Okay, that's decent.
And he's got some nice pictures here of what it looks like. That is super dense.
A disk monster.
I've built a 1 petabyte machine before. It too comes out to about 1,400 terabytes raw with 1 petabyte usable. Although I wasn't space constrained, so I actually went with 4 4U shelves that hold 44 disks each for better cooling. But, if you're space constrained, then yeah, a chassis that holds 90 or 100 disks in it will give you more than double the density.
Okay, yeah. Considerations that will pay off later in the long run.
Yes. He also notes that make sure your rack is deep enough. This machine needs a rack that is at least 1,200 millimeters deep to fit the monster. The picture doesn't really show, but I wonder if you're actually loading the disks dual ganged or something.
Hard to tell.
Yeah. But yeah, that's quite a machine. He's also got a preview of the tie-in lights out management system. It's interesting. I've never actually used a tie-in machine before, so I've not seen their thing, which is actually quite nice looking.
Mm-hmm.
And shows the HTML5 console so that you can get to the machine. And then they show in the boot up screen, you can see they selected their 2 Intel SSDs for
a RAID or something?
The OS to boot off of. And you can also see all the other hard drives in the machine.
The long list.
Yep. So they threw FreeBSD 12 on it using a default installation with ZFS mirrored across the 2 SSD disks. And they used that setup with boot environments and so on. So that'll be very nice. Then they broke up the disks into 7 RAID Z2 sets of 12 disks each, with 6 spares, adding up to 90 drives.
Mm-hmm.
When I did my setup, I think we did 12 wide as well, but we did RAID Z3, and so we used 3 disks from each of the 4 shelves in each VDEV. So if any one shelf goes offline, the parity means the pool stays up, even if we lose 3 disks out of every one of the RAID Z3s, so that if a cable gets yanked out accidentally or something, it doesn't fault the pool. But in their case here, it's all in one chassis, so it doesn't matter.
Mm-hmm.
And so he's got the very nice cam control dev list output.
In its glory, yeah.
Yeah, all 92 drives available there. And then they use the sesutil command to turn the locate LED on for a specific drive.
Mm-hmm.
So DA64 now will be blinking its little replace me LED.
Yep.
And you can see that, yes, the 12 terabyte drive provides 23 billion 512 byte sectors, or more likely they're probably 4K sectors, I think, at that size. But now you get it. A nice little for loop they wrote here, or while loop, to take the output of devlist, find all the Toshiba drives, and destroy the partitioning, create a new partition table, and set it up with a ZFS partition.
Mm-hmm. The GPT, of course. Yeah.
Then they do the zpool create, pool they're calling NAS02.
So this one, I would have used the -n flag to just make sure I get the right RAID groups.
Yes.
Because if you mess that one up, that is...
Well, if you notice right away, you can just zpool destroy again.
Yeah.
If you do zpool create -n, then your big command, it will give you the output of zpool status, basically, showing you how it's going to lay it out so you can make sure it's right before you run it.
Yeah.
Less important during the initial create. Super, super, super important when adding an extra VDEV to an existing pool.
Oh, yeah.
Because if you screw that up, it can be really hard to undo.
Mm-hmm.
Sometimes impossible. So yeah, -n, super important. Which actually brings up another thing. Somebody from Illumos is working on adding ZFS create -n for before you create a dataset or a ZVol, where it can tell you things like what the reservation is going to end up being. So it can do all the math and figure out how much space it's going to need to create it without actually creating it.
That might come in handy, yeah.
Yep. And then they have the output of zpool status, which is very pretty with that many disks. And he talks about some of the other settings, like turning compression on, A time off, setting the record size, and creating their NFS and SMB roots and setting up iSCSI.
Oh, yeah.
And they talk a bit about some of the setup of that. Enabling ZFSD, the fault management daemon in FreeBSD, so that it will automatically replace the failed disk with a spare. Setting up the bootloader. In this case, they're actually disabling prefetch on purpose. Depending on your workload, that might be better. Sometimes it's worse. They're also disabling cache flush, which I don't recommend. It definitely makes things faster, but ZFS has asked the disk to flush its cache to the right cache. It's kind of important that it actually does that. Unless you're okay with losing the last couple seconds of data during a crash or a power failure or whatever. Anyway, he sets his min and max arc size and disables the ZFS deadman switch, which again is suspicious. But anyway. And then he shows setting up the network, lagging together to the two 10 gigabit network cards, configuring the switch to do the link aggregation for them as well. Basically walking through the rest of that.
That's a fun project for sure.
Yeah. So they looked at some other options for building this. The Dell EMC data domain, for example, the data domain DD9300, it cost 10 times as much and took up 14U of space instead of 4U.
Yeah. So there's that consideration. Oh, yeah. They're doing some benchmarking at the end.
Yeah, with iPerf, and they were able to get the full 10 gigabits. One NIC. They ran disk info on some of their large disks there, and you can see they got good throughputs. Reading 1 megabyte blocks, or it's getting about 214 megabytes a second.
Very, very nice.
Looks like once they created the ZVol read rate was over 2.7 gigabytes per second.
Ooh. That's certainly a nice way of pushing some bytes around, bits.
Yep.
Yeah, so in case anyone is trying to build a similar setup and needs some notes, Vermiden has you covered.
They were getting 3 to 3.5 gigabytes per second with a couple of different DD processes running at once. They also tried some other benchmarks and so on.
Yeah. Dig deeper. We have everything in the show notes if you want to get all the latest details and just drool over the setup a little bit. So, the other article that we have is the death watch for the X Windows system, aka X11, has probably started. This is from Chris Seibenman. We covered his articles a couple of times on the show.
Quite a few times. He's often talks about ZFS and the internals of it and just general Unix fun.
And this time it's about X11 or the X Windows system. And he writes, I was recently reading Christian F.K. Schaller's On the Road to Fedora Workstation 31 via both Fedora Planet and Planet GNOME. In it, Schaller says in one section about GNOME and their move to fully work on Wayland, quote, once we're done with this, we expect X.org to go into hard maintenance mode fairly quickly. The reality is that X.org is basically maintained by us, and thus once we stop paying attention to it, there is unlikely to be any major new releases coming out, and there might even be some bit rot setting in over time. We will keep an eye on it, as we will want to ensure X.org stays supportable until the end of Red Hat Enterprise 8 lifecycle at a minimum. But let this be a friendly notice for everyone who rely on the work we do maintaining the Linux graphics stack. Get onto Wayland. What is there? The future is. That is where the future is. Sorry. So, unquote.
So, somebody from Red Hat basically saying that after Red Hat 8, they don't expect to be bothering with X.org anymore. And as they are the de facto only people maintaining it, that would leave it to rot very quickly.
Yeah, and then everyone should be on Wayland or make a move to it. So then Chris writes, I have no idea how true this is about X.org, the X server maintenance, either now or in the future, but I definitely think it's a sign that developers have started saying this. If GNOME developers feel that X.org is going to be in hard maintenance mode almost immediately, they're probably pretty likely to also put the GNOME code that deals with X into hard maintenance mode. And public GNOME statements about this, and public action or lack thereof, provide implicit support for KDE and any other desktops to move in the direction if they want to, and probably create some pressure to do so. He's known that Wayland was the future for some time, but he would still like it to not arrive anytime soon. as he's quite attached to his window manager and he very much likes X only. He's not holding his breath for anything very much like it, especially not as far as something like FWM Icon Man. So, GNOME's view especially matters here because of GTK, which is used as a foundation by a number of important desktop programs such as Firefox. Not Chrome, which apparently has its own toolkit system, but if Xorg or X support decays in GTK, a lot of programs will start being affected. And I don't know how receptive the GNOME developers would be to fixes if they consider X support to be in the hard maintenance mode. But a lot of this is worries rather than anything concrete. So, and he closes with PS. I have no idea what non-Linux Unixes are going to do here, especially for NVIDIA hardware, where driver support is already lacking and often at the mercy of NVIDIA's corporate priorities and indifference.
FreeBSD is finally getting in a good state for graphics, and so, of course, they're going to kill Xorg.
Once we're almost over the finish line, yeah. But I guess work is going on. I think I saw a couple of years ago thing, an early try for Wayland on FreeBSD or on other BSDs. So
yeah, but
some things die hard very slowly, and maybe someone else will pick up some kind of Xorg maintenance work. Okay, time for the Beastie Bits this week. We start off with porting NetBSD to risc-v. It's a YouTube video that we found.
Well, no, it's from BSDCan.
Oh, right.
It's a video of the talk from BSDCan.
Of course, recordings. Haha. Excellent. For the people who couldn't make the conference see it live, then you have the video of that effort. So risc-v is definitely going to be interesting in the next years, or actually with the ARM ban currently going on. The RISC chips might become more and more important for manufacturers of little mobile phones or tablets even.
Yeah, it's already been used in some interesting places, including Western Digital using it for the microprocessors on hard drives, and I think NVIDIA even was using it for some stuff on video cards. So
that's certainly an architecture people should take a closer look at. Then we found that FreeBSD 11.3 RC3 is available, so that's almost out the door.
Looking at the changes since RC2 includes a fix for a regression in mountd and a regression in the NAT64 LSN translations. I remember the NAT64 one I remember seeing some tweets about, so good to see that they managed to get that reported and fixed.
Yeah, so the people on the 11 train can still benefit from that.
Yeah, the 11.3 RC2 versus RC1 included an update for the Intel IXL and IXLV drivers.
Yeah. Yeah, some backports.
And RC1 included a bug fix for the Mellanox 5EN driver, some USB fixes, some ZFS boot and BECTL fixes, and an updated version of OpenPAM. And a panic in vimage were all fixed. Just goes to show how important actually testing the RCs with your workload is, because it's what determines that you will be able to actually, that the release will be good for you.
Oh yes, yeah. Test it out, there are snapshots available, and report if you find anything, otherwise it will be part of the release, which we don't want. Then we have open source could be a casualty of the trade war over at bunnystudios.com. It's a longer article about the thing that's currently going on in politics or in worldwide trade wars, if you want to call it that.
Well, Trump Executive Order 13873, which is the Securing the Information and Communications Technology and Services Supply Chain, which basically added Huawei to the Export Administration Regulation list of places you're not supposed to trade with or whatever.
Yeah, so that has the impact on the IT industry as well.
Yeah, so they have interesting globalization thing here. So when I heard that ARM was going to stop doing business with Huawei, I was a little puzzled as how a British company owned by a Japanese conglomerate would be affected by a U.S. executive order. The BBC report indicates that ARM has concerns over its U.S. origin technologies. I discussed this topic with a friend of mine who works for a different non-US company that has also been asked to comply with the ban. He told me that apparently the US government has been sending cease and desist letters to some foreign companies that derive more than 25% of their revenue from US sources, threatening to hold their market access hostage in order to coerce them into not doing business with Huawei.
Yeah, and that has impact in many ways and in different forms. And the article basically deals with that or discusses some of the implications.
But then later, a couple pages in, they have their collateral damage section, which talks about open source. The trade war also begs a question about the fate of open source as a whole. For example, according to the 2017 Linux Foundation report, Huawei was a platinum sponsor of the Linux Foundation, contributing over $500,000 US, and were responsible for 1.5% of all the code in the Linux kernel. This is more influence than Facebook, and more than Texas Instruments, and more than Broadcom. Because the administrative action so far against Huawei relies on export license restrictions, the Linux Foundation has been able to find shelter under a license exception for open source software. However, should Huawei be designated as a foreign adversary under that executive order, it greatly extends the scope of the ban because it prohibits transactions with entities under the direction or influence of foreign adversaries. The executive order also broadly includes any information technology, including hardware and software, with no exception for open source. In fact, it explicitly states that openness must be balanced by the need to protect our country against critical national security threats.
So they're using this loophole at the moment, but it's not clear how long they could do that.
It's not a loophole, but
some special thing. Yeah, anyway, we'll watch this space, and the news will unfold eventually. Next item that we have is Celebrate Unix 50 and SDF 32 over at sdf.org.
So on July 10th from 6 p.m. to 10 p.m. at the Living Computer Museum and Lab in Seattle, Washington, the Unix conference attendees and SDF members and Bell Labs alumni will enjoy snacks, several restored mainframes and mini computers running different versions of Unix, including a DEC PDP-7A running version 0 of Unix, the UNICS version, the old one, a Honeywell 6180 panel running Multics, an Interdata 7/32 running 6th edition Unix, a PDP 1170 running 7th edition Unix, a VAX 11780-5 running 8th edition Unix, a VAX 11730 running 4.3 BSD, and a PDP 1184 running 4.11 BSD. There's also a former SDF AT&T 3B2/500 running SVR3 with a BLIT graphics terminal, and more. And apparently, if you're unable to attend in person, because you don't live in Seattle, a live stream with interactive chat will be available.
Oh, okay. That's something to catch the action.
If you're into the history of Unix or retro computing, definitely check it out.
And last but not least, in our Beastie Bits, we have the DoS Environmental Security over at the OpenBSD journal on deadly.org.
Yep. So Ted Unix goes on after mailing this post that after some reflection, I've been convinced that it's unlikely everybody reads the manual or that the manuals are even complete or correct. So the new do-as behavior moving forward is to reset most everything in the target user's environment. Your action items, as we'd like to say in the biz, are to check your existing configs for the restricted root rules and verify that they are run with the correct environment. And when updating, check for rules that intentionally use inherited environment variables that may need to be explicitly passed using the setenv in doas.conf. So basically, to avoid things leaking from the environment of the regular user to the root user, or somebody being able to set something in your environment and tell you to do as or sudo, it will basically only pass through the variables it knows are safe or ones you specifically tell it to.
Okay, that's good advice to heed.
Yep, mostly it's a heads up to watch out for this change when you upgrade.
When the new version is pulled down, yeah. Be prepared. Okay. All right, it's time for feedback and questions this week. We have 3 people who send us an email, but you could be the next one. Why don't you send us something if you have a question, a comment, a show idea, or something that you found on the internet about the BSDs, any BSD. Send all of that to feedback@bsdnow.tv, and then this section will be less empty. So the first one who did this week that we cover is Matt with BSD or older hardware. It's short, but nevertheless important. Matt writes, "Hello, gentlemen. I have recently installed Antix GNU Linux on a Dell Inspiron 3800 with a 700 MHz P3 CPU and 128 megabytes of PC100 RAM. Don't laugh. We all had these systems at one point." So he writes, "I was wanting to know if there was a BSD available that would work on this hardware. I also use a D-Link PCMCIA wireless card. Would this setup work well with BSD? Thanks."
I don't know about the wireless card. Other than that, a very modern version of FreeBSD will probably struggle a bit with only 128 megabytes of RAM. So your choices are an older version like that, or if you go with something like NetBSD, or I imagine OpenBSD even would work. In general, everything was going to work with the Pentium 3 hardware. That'll be fine. It's just how constrained things are and how kind of bloated might be the wrong word, but even FreeBSD will probably work. Just you're not going to run Firefox on a machine with 128 megabytes of RAM, right?
Yeah.
So it really depends what you plan to do with it, what makes sense. But yeah, any of the BSDs should work with that. I have no idea about that wireless card, though.
Yeah, it will probably be the most difficult part to get it working, but you should be able to install the system just fine.
All the BSDs still have i386 support for old machines like that.
That will certainly be a nice blog post, like how did you get this far, or how much you struggled with some of the parts.
Yeah, I guess, a bunch of people, like if you're doing it for a machine that's not going to have a graphical interface or whatever, lots of people do 128 megabyte or 256 megabyte VMs. So
right,
it should just work.
That will certainly be a nice weekend project. If someone else has a similar setup like this, then send us a follow-up email, and then we can compare the notes.
I think all of my Pentium 3s went to the recycler.
Yep. It's like that belongs in a museum kind of thing. But they kept us when they were the current systems of those times. That was a nice machine to work with because we didn't have anything better. Okay. So thanks, Matt, for this question. And next up is MJ Rodriguez with some PlayStation news. He writes, "Hello, Alan and Benedict. I found a piece of news relating to the PlayStation 4 and PlayStation Vita, both of which run on FreeBSD, as you've covered. Yep. One is an emulator for the console that is starting to boot. The interesting part here is that it's a low-level emulation using QEMU. You would read the article yourselves and pick out the interesting parts. What is left is to install the actual operating system firmware and get it booting. From there, emulation becomes more simple. And relating to this, I've understood that the man who led the system architecture team for the PS4, Mark Cerny, also worked on the PlayStation Vita beforehand, which it appears also runs FreeBSD. Another handheld, the Nintendo Switch, appears to run FreeBSD as well, at least its kernel. Userland is apparently being proprietary. Sorry for the rambling email. No, it's not too long, but I had a lot to say."
Yeah, it's a little unclear how much of the Switch runs FreeBSD. There's definitely some FreeBSD code in it. It's just not clear how much. Whereas with the PlayStation 4, that was definitely just an entire FreeBSD 9 kernel and user space and so on, and then just with a different syscall table and all the Sony extensions on top of that to try to make it, basically, to bootstrap their OS faster than having to write one from scratch. With the PlayStation 3, they basically assembled their own OS by borrowing bits from FreeBSD and NetBSD as needed. And it turns out it's just faster to just start with FreeBSD and build what you need that's missing on top of it than to construct your own thing.
Yeah, write your own operating system for a gaming console. Yeah, use what works and then build on top of that. Certainly good to know. And if we have more news in the PlayStation area, then we'll cover it also on the show, of course. The last this week is Mortis with Beehive VTX Passthrough. I see where this is going. Goes like this. "Hi, long-time listener, great podcast. Thank you. Every week, the new episodes makes me happy. Well, great. That's good to know. Now for some questions. Are there any plans for Beehive VTX pass-through so you could use virtualization inside a Beehive VM?
It's definitely a frequently requested feature, and interesting because that VTX pass-through in, I think it was VMware, on a Mac is how the very initial versions of Beehive were developed. And so, yes, it would make even just Beehive development easier if you could do Beehive in a Beehive. But apparently it is very, very tricky and would increase the complexity of Beehive a lot and may not actually be worth it. No one's saying no, but no one is actively working on it.
Yeah, so there's that. Maybe someone will pick that up in the future, but...
Yeah, if someone has the skills to be able to work on that, that'd be great. But the people who are working on it are trying to get other features done first, trying to get the suspend and resume and migration and all that kind of stuff done.
Yeah, we recently got the HD audio support. That is nice.
And I think actually the review for the pause migration stuff is actually going through feedback right now.
Oh, also good. So yeah, sorry for butchering your name. It's Moritz, not Mortis. Little typo there. Not a problem. Thanks for the question. And again, if you have something Beehive VTX related, you will definitely cover it in a future episode. So yeah, that's the end of this episode. Thanks for watching, of course, and see you, or no, not see us. Still falling into that trap. Hear us next time.